Okay, hello. We are going to deal with part two, and this is the purpose of this part is the modeling the warehousing Autodesk robot. For this purpose, we need to choose a frame template. The name of this frame template is 3D frame. For that one, we are going to define the structural grid lines. That is we have a span width in the x direction axis with 5 meters, and the repetitions number 6 we get 30. In the y-axis we have 40 meters, which means with 5 meters of span width we need a repetition of number 8 times. In the axis we are going to put the letters, and which is that one, 40 meters. For the height of the building, we have first we have the reference level, which is 0, but we need to choose value 0 at the reference level. For the columns, we need they will be placed at the top of the column, that's 6 meters. 6 meters. On the top of the truss, it will be placed at 8.5 meters. Yes, and we needed the value, and we applied this configuration of the structural grid lines. We check our definitions, and there it looks like very good. And the next part, we are going to take the columns. After the definition of the grid lines, we are going to define the columns. For that purpose, we use the definition here. We will see we have a HV 300. Yes, we changed the plane here to X theta, and there we use a column correct from this point to this point, and in the other grid number 7 we have the 2 columns over there. We have a look at that. Yes, and we need to see the shape as well. Here you see the arrow, the red arrow is in the direction of the upper flange is outside, and in the other one is inside, which is not correct. We need to rotate. So we rotate 180 degrees. So now it's correct. We mark the 2 columns, and we are going to make some copies from these 2 copy and a repetitions from this point to this point. So we have all the columns here. So from all columns we need to make a group for these ones. So the group would be new group, and the name would be columns, of course. Columns. This procedure will facilitate it to make the design later on on the software. Yes. Right, in this moment we are going to see how to define the truss. To that purpose, we need to turn off some stuff here as the shape. We go to the X theta plane, and we choose a template from the menu. A triangular truss. We put the length, which is 30 meters. The height is 2.5 and the number of fields 12 in this case. The sections here we will define in the Europe group HEB 300 as a starting point. Later on, we after the analysis and design, we are going to change perhaps this one. There's an approximation here. We copy this HEB profile to the lower chord. Yeah, happy about that. And we define the diagonals, an angle of 77, right? Yes, here as well. The posts. The insertion point of the truss would be here. Apply and OK. Now we are very happy about that. We look at the 3 dimension of this truss. Yeah, that's correct. Again, to the XY. We are going to copy this stuff to the other planes. We select this stuff, go to the 3D and edit, copy. We're going to make 8 copies of this at the beginning point of A7 to that one. Nice, beautiful. So we have all this stuff here. Now we need to make groups from these things here, which are going to facilitate the analysis and design of these steel structures or truss. So we take a front view in that way. Okay. And we make, for example, for that one, we choose all this stuff, the upper core. Good. We are going to make a group of that. Yes. Group. Name upper core. So in the same way we make the grouping of the underlying stuff and the core. We make a group over there. Okay. The lower core. Yeah, of course. And afterwards, we're going to choose a little stuff here. For example, the post here. So another one. That we see how many there. Yes. And we choose another group here. and we call that group posts. So, and finally, we make a group of the diagonals. That one, that one, that one. This procedure is very important to give us versatility in the analysis and design of the structure. So we are about to the end of this grouping. Yeah, correct. And that is another group, and we call that group rename diagonals. Yes, we will see what happened here. For example, if I choose that one, say show active exit. Yeah, refresh selection, for example. We see we have only the diagonals here. We choose only the post for making the analysis of dimensioning or design. We see over there the posts. And the same like the other one. Ah, very good. Yes, now it's time to make their side rails. For that purpose, we go to the, we will see, X, zeta, Y. Yes. And we need to put another definition, X definition, and the plus, and the zeta level. We need to put the sum 1 to 0.5. Apply. 0.5, maybe with the name 0.5, and the name is the value here. Position 0.5. That's correct. Apply. Close. And we're going to put here side rails. We will see what we have here. We need 160, for example. To create that one, we got to this stuff here. We need UP Europe, UP 160. We add that one. It must be a bin. We check that, and of course the steel could be 355. Still right. Okay. Yeah. So close. We're going to use a pin here. You up in that way from the point to the other point here. So we look at the 3-dimension there. We check the top of flange and the shape of the, yes. So this we might must be rotated. We go to geometry, and we will rotate the minus 90. So we will see, yes, that's correct. Oh, I see that. We are going to make a copy of this side rail. First, is that correct? Let me check again. Yes, that's correct. I'm checking the top flange. That's the right position. Why setup? Okay, we take that one and make copy. I want to what be 0, 0, 8.1, 8.1.8. Execute. We see that's correct. We check the other side, right. Okay. We select the 3 ones. That way. Oops, that is something that we don't want. Okay, this and this. Edit vertical mirror. We take 15. Execute. So we have on the other side of the building. We check how it looks like here. That's not correct. We need to change geometry. Properties, local bar direction, apply. Okay, we will see about the top flange. Yeah, that is correct in that way. Yes, to the right. We take all the side rails on this side. That one. Edit, movie. We need to have 7. I will take for this from this point to this point. Okay, so that's the side rails. We need to make a group of this stuff. Before we finish side rails. Yes, so the group could be so the whole side rails for this long side. We go to groups and we make a group of that. Side rails. Side rails long side. Yes. Yes, this moment will be to put the column, the wing columns for horizontal loading. So we make some columns here in this plane, which is X zeta, and we will choose wing columns like EHB 200 as a starting point. One here, the other in this grid line. We have in the number 5 as well, and we have in the number 6 grid line. We close, we check these columns, their orientation. For that, we need to turn on, and we see that the orientation is not correct. Yes, so we need to select these 4 columns, change the angle to 90 degree, and look at the top flanges. They are correct right now. We get back to the plane X zeta, and we will put some side rails here. Beam, we need UP 160. Close, check again the orientation of this beam. It's not correct. We need to rotate some degrees, 90. Geometry, properties, and local bar direction. We will see this correct right now. That's correct. So we get back to the plane X zeta. We can make some copies to the other levels. Here, I'm going to make a copy, 2 copies here. So we say 2 copies, and starting 0, 0, 1.8 meters. Execute over there. Close. We copy this stuff here. From this point to this point. Okay. And we need to copy this as well. Select one, copy. From this point to this point. Yes, from this point to this point. So we have all this stuff right now. We close. We take all this stuff to copy to the other side of the structure of the building. Yes. And edit, copy. From this point to the other point there. So we check the orientation of these beams and columns. We will see that the columns are in the ground direction, so we need to change the direction of the columns so the top flange is looking outside. So I think so 270 could fix that. Right, it make it. But we need to correct the beams as well. We take that once. There. 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 And there. Yes. Geometry is the option here, and local bar direction. So, okay, very good. It looks like we are going in the right way. So x theta again, but not in the 0, 0, but in the level 40 meters from there. We are going to create a column and beams here because we don't have support here. So we need to complete copy from here to here. That's correct. And the next step, choose the 3 beams, copy from this point to this point. So, right. We'll look at the 3 dimension here. Look how it looks like. Yeah, we have managed quite all right. Yes, this is the wing columns with some side right walls. We need to make some groups for these columns, so maybe we make right now. Turn off that one on the columns. Wing columns. That's the guy. The issue to make group. So we take the wing columns here, and we make a group over there. New group. The group is, the name will be wing columns. That, and the side rails. That. This ones. That one. We check if we have all that stuff. Yes, we have that. A new group for that stuff here. And we rename side rails, short side. Okay, now we finish with this moment. This moment is to create the beams to this building. For that purpose, we are going to use an IP 200, and we put over there. We mirror that one to the other side. That's correct. We selected it to just do that, and we make some copies of this stuff. We're going to make 7 copies. Yes. We make a group of these beams. That one, right. We call the group Eve beams. Yes, we save it that one. Right, we have arrived to the creation of purlins on the roof of this warehouse. For that purpose, we need to choose those 2 beams and divide it at the beginning of the beams. I will put this at distance 0.2. We turn on the nodes, and the nodes give me 325 at 326, and the other side will be is 1521, so I will put this in 15. 15, 2 nodes over there as well. Right. So I put the polling here for the first, which is a beam 160. Between this point on the other point in the other stream. So at the end of the other side here. Yes, there. Yeah, already. We turn off this view and we check the orientation of these pullings. Where is the other pulling here? Yeah, we have over there. These pullings must to lead the same slope as the thrust, so we need to change the angle. Now is and we have 2.5 and 15. The art tangent minus 1 would be the angle would be minus 9.46. So yeah, we control the upper flange, how is oriented this, that's correct. We need to give the same orientation to the other being here. It was minus 9.46. Okay. The shapes, you could look at that. Yes. Yes. Okay. We can turn on the off this stuff, and we can copy it to the other parts. That the Pauline's copy. Yes, from this point to this point, from this point to this point, from this point to this point, and so on. Happy about that. We check to the top. We select this stuff here, there, and we create a mirror, vertical mirror in 15. Right. And we need to check the orientation of this new stuff. Here, there is no correct. They are oriented to the other side. So we view geometry properties, local orientation, apply, close. We'll look at the orientation of this stuff here. Yeah. Okay, that is quite correct. I think so. So we're happy with this modeling moment. We need a little more here. We go up and we are going to select all this stuff here. How many there are selected? Okay, we have 14. 1, 2, 3, 4, 5, 6, 7. Multiply by 2, that is 14. Okay, so we are going to copy this 7 times. Yes. And we will copy from this point to this point. Nice. Very good. Yes. We take a look of the plan view of the roof. I like it. And we need to make a group from this stuff here. So before I finish this moment, it will be to make a group for this. That is 14. Yes, of course. And 14 more. Yes. Okay. soon we are going to finish this moment. Maybe we think that we don't need it, but this will be a very good procedure to manage later on the analysis and design of the buildings. That's why I'm doing this stuff. Okay, we have 112. We make a group of this stuff here. We are calling pullings. Yeah. Okay. We are finished with this moment now. This moment is about creating the bracing. So we take the Y theta elevation, and here we need some beams. Okay, maybe we need a CA angle like that. Yes, European. No. Yes, over there. And we can take 112. The grade of the steel construction, of course. Yeah. So we take that from this point to this point, or from this point to this point. From this there, or from there, the other side. We need to look at the three-dimensional, right? I put some more in on the roof as well. From this point to this point, from this point, and so on. This there. Okay, I think we are near. Yes. We should check the orientation for this stuff. Yeah. That's okay. Yes. We select this last one. Was this right? And we make a mirror, a vertical mirror, 15 meters here. Close. And finally, we select again this stuff. So we make a copy to the other side. From this point to this point. Oh, oops. We make we are going to mark the whole stuff here. This one. So we'll make a copy. Yes, we need to make as well a group for the bracing, which is the final moment. That one, make a group here. We rename this as bracing. So in principle, we have done the modeling of this warehouse.
Correct. We are arrived to the part we are going to export this model in Autodesk Robot to Revit. The main purpose to make this is only to make checks in this stage. Surely the model need to make adjustments later on, but to check only if there is if I am quite happy about that. So to make this I choose from the menu the integration Autodesk Revit structure, and it's quite simple to send this to the Revit. I have already opened Revit, so it will be sending this to Revit. If you remember, we have been discussed in part 1 for this industrial project the design concepts of the warehouse industrial building, things like geometry, stability systems, and things like vertical coordination of the structural zones, horizontal coordination, span range of structural systems, and things like that. So here in this stage we will I want to capture the things that I need to think about for later adjustments in either in Robot or for making drawings in Revit. So we are going to check now is already, and we can go through the warehouse in Revit. Here is the warehouse. So we need to take some views here to make the checks. So we use a view structural plan, and here we have some plus levels. For example, I want to check in reference level, so I pick that one, and I want to check at the roof level as well, so I take that one as well. Maybe I don't see the whole roof, so I need to make a little change here to the view, which is the view range. It's a very simple, only unlimited, and that way I can see the whole roof. Okay, right, and I would like to have a check for this building at the some section here at the middle. approximately here. I want to see how the beams and the columns has been exported to these Revit structures. Okay, so we can open over there, go to the view. I can move this to the other screen, and here we can see some issues that I make to think later on when I'm going to make the drawings. For example, we have the levels that we have defined at the beginning of this tutorial, but as you see, for example, their side rails, they need to be at the center of the line. That's one issue. The other issues that you see is the upper core and the lower core that are not exactly correct. It's very easy to make changes over there, as well as the pullings. The pullings needs to move to a higher level, and you have some issues here. As you see, the post and the diagonals that are not so quite nice. They made in the later when we are going to make the drawings, we are going to correct all these issues. But geometrically, I would say that I am quite comfortable with this section, and the other sections, they are in the same way. Maybe I need to check the dimensions of the structural grid lines. So I would like to check very easy. Maybe I need to change the scale to a higher scale, and the width, it could be 30,000 millimeters. That's good, correct. And in the other, the length of the building, which is 40,000 millimeters. That's correct as well. Yes, so I think that I can continue to work with this model. The bracings that are quite okay as well. So I am quite happy with this check. Later, when I have done in robot the calculations, the analysis, and the design, so this model will be exported again to Revit. Yes.